Hi students, how are you? Today we'll discuss satellite and planetary motion. First we'll see what is satellite. Now see satellite and planetary motion. Now see satellite and planetary motion. It is the topic, it is the chapter. But what is satellite? Now satellite is the heavenly body. Satellite is the heavenly body that revolves around the planet. And there are two kinds of the satellite, artificial satellite and natural satellite. Natural satellite means assume the moon is revolving around the planet Earth. Moon is revolving around the planet Earth by 27.3 days. So moon is the natural satellite. But nowadays different countries are sending the satellites for the communication for different kinds of purposes. That is called the artificial satellite, right? So first we will see just satellite, the definition. Now write all of you with me. Now write with me. Satellite, all of you write. Satellite is the heavenly body. Satellite is the heavenly body that revolves around the planet in the circular orbit, okay, that is the satellite. And there are two kinds of satellite. Two kinds of satellite. Now see, satellite, there are two types. Take no. Number one, artificial satellite and natural satellite. Clear? Number one, just satellite. Write all of you. Natural satellite. Natural satellite. Natural satellite and artificial satellite. Artificial satellite, right? Natural satellite means suppose the earth is moving around the earth, a moon is revolving around the earth planet. The moon, right? The moon is revolving, the moon is revolving around the earth by 27.3 days for one revolution. What time is required for one revolution for the moon around the earth? 27.3 days. It is called the time period of the moon, right? No, so it is the natural satellite. Artificial satellite means suppose for the communication purpose we are sending the geostationary satellite. In later time we will discuss in details what is geostationary satellite. But now I am writing here geostationary satellite. Geostationary that is communication satellite. Communication satellite is sent from the surface of earth, from the earth from the earth for different kinds of purposes, for different kinds of purposes. Artificially we are launching purposes, right now. This is called the artificial satellite. Maximum countries are sending for the own communication system. Countries are sending the satellite, artificial satellite. That is the artificial satellite. It is the natural satellite. But my question is how to launch the satellite from the surface of the earth. We have seen in our country, in India, Hoda Institute launches the satellite right now with the help of the rocket. Rocket reaching at a certain height give the horizontal velocity, then the satellite will take the circular path and revolves around the earth. But now we will discuss what is the process for the launching of the satellite. Okay, so now students, please give the heading, what is the launching of the satellite or launching of the satellite. Launching, I am writing here, all of you give the heading with me. Launching of satellite. Launching of satellite. Okay, now see here, assume this is earth's surface. Okay, assume here this is earth's surface. Clear? And also assume, suppose here we are sending the rocket. Suppose we are sending the satellite from this height. Give the horizontal velocity to the satellite like this with velocity v. Assume initial velocity very small. So what will be happen? Due to the gravity, the satellite will fall like this. Right now, this satellite will fall, or any object will fall on the surface of the earth. This is the earth's surface right now. And assume this velocity increase this velocity. I am writing here, gradually increase the velocity, gradually increase the velocity, gradually increase the v. What will be happened? This velocity increase, again the horizontal distance will be more as compared to the previous. Now it will fall like this. Now again increase, now again this will fall like this. But at a particular velocity, the will not get the range. At the particular velocity, the object will not touch the earth's surface. But now see here, just I am erasing here this portion. At a particular velocity, at a particular horizontal velocity, the particle will take the circular path and revolves along this circular path. Right now, at this particular velocity v dash, at the particular velocity, the object will not fall on the surface of the earth. Satellite will not fall on the surface of the earth. Satellite will take the circular path. Curvature of the path the satellite will take and revolve like this. Have you understood? This is the process of the satellite for the launching. Right now, I am writing here, at a particular velocity of projection, at a particular velocity of projection, at a particular projection velocity, the satellite will take an orbit and moves around the earth. around the earth, around the earth. This is the process to launch the satellite from the surface of the earth, right now. If you give the less velocity, it will fall on the surface and gradually increase the velocity, projection velocity, upward velocity increase, then at a particular velocity v dash, it will take the curvature, it will take the circular orbit, and the satellite moves around the earth's surface. Am I clear? So this is the process of the launching, just I have told you in brief. But we have to discuss many kinds of the topic of the satellite. First, we will discuss the orbital velocity or orbital speed of the satellite. Students, give the heading. Okay, I am changing my page. Now see here, another page, the orbital velocity of the satellite. Please, all the students, please give the heading here. Orbital velocity, orbital velocity of satellite, orbital velocity of satellite. Okay, we will discuss. Now see, assume like before, this is the earth, this is the earth. Okay, this is earth, and assume around the earth in the circular orbit one satellite revolving. Assume this is the circular orbit. Okay, this is the circular orbit, this is the circular orbit. Okay, this is the circular orbit. Assume this is the earth, center of the earth this, and radius of the earth are center O, and this is the surface. Now from the surface of the earth at each height one satellite is revolving. This is the satellite, and this is the mass of the satellite, right now, and it is moving in this sense. Assume along this direction, in anti-clockwise direction with angular velocity omega, the satellite is moving like this. Am I clear, students? And also assume from the center to the satellite total distance, assume this distance is r. Small r means capital R, and height from the surface of the earth, center to the satellite. Am I clear? And what will be the direction of the velocity of the satellite along the tangent at any point on the circular path? When the satellite remains here, the direction of the velocity along the tangent V, actually tangent should be 90 degree with the radius of the circle or circular orbit. This is the velocity of the satellite. It is called the orbital velocity. So symbol I am writing here, students, please see, m is equal to mass of satellite, mass of satellite, mass of satellite. Clear? And V, orbital velocity, orbital velocity of satellite, orbital velocity of satellite. Clear? And small r is equal to r plus h as shown in figure. And here capital M means mass of the earth. Capital M is equal to mass of earth. Okay, am I clear? I have written the symbol of V here. But now see, students, this is the satellite having the mass small m. So for any particle, for any object revolves, for the revolving in the circular orbit, one force is required, that is called the centripetal force. For circulation, for any object to circulate in the circular orbit, one centripetal force is required, which acts towards the center. Centripetal force is required. Whose centripetal force? Centripetal force of the satellite. What will be the centripetal force? mv square by divided by total distance satellite to the center of the earth, that is small r. This is small r, mv square by r. It is acting towards the center. I am writing here for revolving I am writing here for revolving in the circular orbit, in the circular path or orbit, in circular orbit, one centripetal force is required. Centripetal force is required or needed. Okay, right? It is necessary centripetal force to revolve in the circular orbit. But from where it is coming? From where? Who is giving the centripetal force to move the satellite in the circular orbit? Keep in mind, there is the gravitational force between satellite and the mass of the earth. Gravitational force between the mass of satellite and mass of the earth. Okay, right now? Now see here, I am telling here. Now see, just erase here right now. Assume this is the satellite here. Okay, this is the satellite. Clear? Up to this distance. Sorry. Now see here. This mass is small m. This is the satellite. Clear? Now see, this distance h, r plus h total. This is the satellite having the mass m. So gravitational force between the satellite m mass and mass of the earth. Now write here, gravitational force between satellite and earth system, between satellite and earth system, gravitational force. Okay, that is F is equal to g, mass of the earth, mass of satellite, and distance between them, r square. Actually, distance should be taken center to center, but the satellite radius of the satellite is very small. That's why we have neglected. That will be like this: r plus radius of the satellite r dash. Total, it will be total whole square, but r dash, radius of the satellite, very less as compared to the r. That's why small r should be neglected. So we have not taken r dash. Am I clear to understand, students? So we have taken r square. So gravitational force Fg, and this force is providing the required centripetal force, to move the satellite, in the circular orbit, right now. So that's why we can write here, centripetal force mv square by r is equal to g into m divided by r square. One r will be cancelled here, r, small m, both sides will be cancelled. Then v square is equal to gm by r. Now see here, students, please check it. Right now calculation is very easy. So now from this, v square is equal to this one. So finally what will be the value of v? So now see, v value will be a root over of gm divided by small r. R means, again I am telling here, R means center to center tak. The distance between the center of earth and to satellite, the distance is small r. But now see here, the orbital velocity or speed does not depend on the mass of the satellite. Now see here, root over of g m. M means whose mass? Mass of the earth. But orbital velocity of the satellite, it does not depend on its own mass. Am I clear? I am writing, seeing this formula. Here I am writing here, orbital speed, the orbital velocity does not depend upon on its own mass. Own mass means whose mass? The mass of the satellite. It does not depend on small m. Seeing this formula, we have to say. Up to this clear, students? Right now, please copy this. So, I think you have copied this. I have understood. Any objection, students? You have understood, no? Okay. So now I am changing my page here. Again this formula, assume this is the equation number 1. I am changing. I am going to the next page. Okay. Now see here. Now see, V orbital velocity, we have got the formula V is equal to root over of G by M. Right now? So here see, V depends upon the some factors. V is inversely proportional to the square root of the distance. And V is directly proportional to the square root of the mass of the earth. Right now? So from this equation number 1, see, assume this is the point number 1 and this is the point number 2. Here see, from point number 1, if R increases, V what will be? Decreases. Inversely proportional, no? R increases, so V decreased. R increases, so V decreased. Means from the center of the earth, orbit radius increases, orbital velocity decreases. And it will be the more speed or velocity of the satellite nearer to the earth's surface. Right, no? And also R decreases, V increases. I have told this one, no? From this relation, see, M increases, directly proportional, V increases. M decreases, V decreases, directly proportional. So we have seen here the 2 points, and also we can say another term here. From number 2 point, we can write here, see, students, V directly proportional is square root of the M. M means whose mass? Mass of the earth. Earth like as the solid sphere, no? Earth like as the solid sphere. Before page you have seen here, this is the earth. It was earth. And radius of the earth, what was? Radius of the earth was capital R. And assume density of the earth is rho. So what is the mass? Volume into density. Solid sphere volume 4 by 3 pi r cube into density rho. Volume into density is the mass of the earth. It is mass of earth. This is earth. Okay, no? So now, instead of earth, we are writing this equation here. 4 by 3 pi r cube into density rho. Now see, from this relation, it depends upon the some factors also here. V depends on the radius of the earth, of the planet, right now. So V directly proportional is square root r cube. Clear, no? That is V directly proportional r to the power 3 by 2. Means here, R increases, so V also will be increases. R decreases, V also will be decreased. And also see, velocity directly proportional to the square root of density. V rho increases, V increases. Rho decreased, V also decreased. Right now, square root this one. So from this relation also we can establish this formula here. We can compare here V2 by V1 root over of rho 2 by rho 1. Just density. Rho 2 means density of other planet. Rho 1 is another planet. V2, V1 the orbital speed of the satellite. Which satellite is revolving around that planet? We can compare this one. Also from this relation, we can write here V1 by V2 is equal to R1 by R2 total power 3 by 2. With the help of this formula, we will be able to solve the different kinds of numerical. That's why I am establishing this formula. Okay, this is 3 by 2 from this relation. Clear, no? So we are seeing orbital speed depends on the density of the planet. Orbital speed of the satellite is depending on the density of the satellite, is depending on the radius of the planet. Am I clear? Okay. And also see previous page. Now see here, small r was r plus h. H was the height from the surface of the earth to the satellite. Right now, I am coming to the next page here. Instead of V, this formula can be written here like this. V is equal to root over of Gm small r means r plus h. This is orbital speed of the satellite. Right now, so we have got this expression. This is the expression of the orbital speed, orbital velocity or speed of the satellite. Right now, orbital velocity or speed. Okay. Now see. So what will be the time period of the satellite? Please write here the time period of the satellite. Okay. Time period means for one rotation, which time is required? For the one complete rotation, for one complete revolution of the satellite around the planet, that is called the time period. Right now. So previous picture, now see here. Okay. This picture I am using like before here. Now see here. Assume this is the, in this page please see, this was the orbit of the satellite. Right now, this is the orbit of the satellite, and this was the height h, and planet is satellite like this having mass m, velocity was v. For one complete rotation, which time is required? That is called the time t. T is the time period of the satellite. T symbol, time period of satellite. Time period of satellite. What will be the time period? Time means total distance by speed. Total distances by speed. Right now. So time period and total distance matlab circumference. Total distance is circumference of the satellite 2 pi r plus h divided by orbital velocity v. And now here see 2 pi small r or r plus h here. V means what? Tell me. V means root over of Gm divided by r plus h. Clear? Up to this clear, students? Am I clear? Now see here. This root will go in upward direction. Then we can write here 2 pi root over of r plus h into r plus h divided by root over of g into m. Clear? After calculation, root over of r plus h into r plus h root 1. After calculation, half into 1 power 3 by 2. Then we can write here 2 pi. It will be r plus h total power 3 by 2, and here root over of gm. Also we can write here same thing, we can write here total root r plus h cube divided by gm. In combined form we have right here. This is the time period of the satellite. Clear? From this relation we will be able to solve the time period of the satellite. But here one condition is what? Suppose h very less than r, means which satellite is revolving from the surface of the earth, that height is very small. H very small, r means nearer to the surface, nearer to the earth satellite, nearer to earth satellite revolving. H very less than, h can be neglected. Then this equation becomes here, then h neglected means it will be r cube divided by g into m. Here right now t is equal to 2 pi root over of r cube by gm. Okay students, up to this please copy. I am discussing the next. Okay, I think you have copied. No students, you have copied. Okay, now see here, I am going to the next page. Now see students, t is equal to 2 pi root over of r cube divided by gm, right? But in previous classes we have seen here on the surface of the earth the gravitational acceleration, this is the earth, again I assume here this is center and this is the radius of the earth is capital R, right? On the surface the gravitational acceleration gm by r square, and gm value is equal to g into r square. Now see cross multiplication. Instead of gm we can put here the value 2 pi root over of r cube. Gm means what? G r square. R square cancelled in r. Then 2 pi root over of r by g. Right? So here 2 pi root over of r by g, it is the time period for which satellite, one condition is here, which satellite is revolving nearer to the earth surface, very nearer to the earth surface, then the time period will be like this. T is equal to 2 pi root over of r by g. Right now? So we will be able to find the time period from this formula. Assume this is the equation number 1, time period for the closer satellite to the earth surface. And also we will discuss for the closer satellite. For the closer satellite, very closer to the earth surface, closer satellite which is closer to the earth surface, closer to the earth surface, right? Then time period already we have got, t is equal to 2 pi root over of r by g. It is the factor number 1 from here, closer to the earth surface. Now see here students, already we have got the orbital velocity. Again I am telling here orbital velocity for this condition, closer. Orbital velocity formula was root over of gm divided by small r, means r plus h. For the closer, height is very small as compared to the radius of the earth, h can be neglected, right now? Then we can write here gm instead of gm g r square, and h can be neglected here, 1 r will be cancelled. Finally this equation becomes g root gr. This is the orbital speed. This is the orbital speed. Now put the value here. G approximately 9.8 into r means 6400 kilometer. Convert into meter 10 to the power 3. This calculation will come here 7.92 kilometer per second, or equivalent it will be 8 kilometer per second. Huge speed. For closer to the Earth's surface satellite, huge speed. By 1 second, it will cover the 8 kilometer distance. Speed. By 1 second, 8 kilometer, the satellite will travel. Huge amount of speed. Closer to the Earth's surface, approximately 8 kilometer per second. And also will be able to the time period of the closer to the satellite. Closer satellite around the Earth. Right now, so we have got the orbital speed closer for the closer satellite and time period also. So in competitive exams, there are so many options are available in terms of other factors. Now see here, I am writing here. For the closer surface, V is equal to root over of Gm divided by R. H has been already neglected. Right now. But now see here, V is equal to Gm by R plus H and H neglected. Clear now? So now see here, instead of M, M means mass of the Earth. M means mass of Earth. Mass of Earth. Clear? So Earth like is the solid sphere. Few minutes ago I have told you, mass of the Earth like this, volume, solid sphere volume 4 by 3 pi r cube into density rho. So put the value here, students, mass of the Earth. Now write here, G by R, mass 4 by 3 pi into r cube into rho divided by r. Okay? Am I clear? Any problem to understand? Clear, no? Up to this clear? Then also we can write here, 1 r will be cancelled, then it will be, and here also rr will be cancelled. No, only 1 r will remain here. Extremely sorry. Right now? Now see, it will be r square. So now the velocity will come in terms of density, root over of 4g capital G r square into pi into rho. It is also the form of the orbital speed divided by 3. Right now, it is also one form of orbital velocity of the satellite. Now see the time period. Time period was r cube by gm. Now see time period, t is equal to 2 pi, that form take r cube by gm. Gm, right now, mass of the Earth. From this relation, see here, students. Now see, t is equal to 2 pi, here see r cube, g, into 1 by mass means 4 by 3 pi r cube density into rho. Clear? So here r cube will be cancelled. Clear? 3 will go in upward direction. Am I clear? So now see here 2 pi, then we can write here 3 divided by 4 g pi into rho. This is the time period. Okay? And assume 2 pi will enter into the root. Then it will be 4 pi square. Then it will come 4 pi square into 3. Then here 4g pi, 4 pi g into rho. Now see, 4 pi square, 4 pi will cancel, 1 pi remains here. Okay? And here 4 pi square only, 4 pi square. Everything is cut. Now 3 pi rho into g. Another form we have got here, 3 pi here rho into g. It is important form. time period in terms of density and universal gravitational constant capital G. Therefore, finally we have got T is equal to root over of 3 pi root over of rho into G. It is important form for the time period. Am I clear? For the closer satellite to the Earth's surface, root over of 3 pi divided by rho into G. This is the time period of the satellite. Am I clear, students? I think you are understanding clearly, no? Okay. Now see here, I am going to the next page. Height of the satellite. Right now, height of the satellite. From this relation, I am going to the next page, students. You have copied, I think, here. Now right here, height of satellite. Okay. Height of satellite. Height of satellite from the surface of the Earth. Now see here. Again assume this is the Earth. Right now. And orbit is like this. This is the orbit. And one satellite is revolving around this orbit. This is the center. Here satellite is here. Mass m. Velocity direction like this. Small r. Height from the surface of the Earth h. Capital R. Radius of the Earth O. R is equal to R plus h. Right now? Am I clear? So time period of the satellite we had got here 2 pi root over of R plus h cube divided by gm. We had got like this actual formula R plus h cube. R plus h cube. Right now? R plus h cube here. Okay. So from this relation, just squaring both sides we can get t square is equal to 4 pi square into R plus h cube divided by g into m. From this relation, see here 4 pi square into R plus h is equal to t square into gm. So here see R plus h value R plus cube. R plus h cube is equal to t square into gm divided by 4 pi square. From both sides now here R plus h only we have to take 1/3. It will come t square into gm divided by 4 pi square. Total power it will come 1/3. Right now? So from this relation h value we will get here t square into gm divided by 4 pi square 1/3 root minus r. This is the height. Expression of the height of the satellite. Right now? Now see here. We have got this expression. We have got this expression height of the satellite. This is h means height of satellite. Height of satellite from surface of the Earth. From surface of Earth. Clear? From the surface of the Earth. Right now? This is the surface. This is the surface. From the surface of the Earth, h is equal to this one. This is the expression. Another term we have to discuss. Satellite is moving around the Earth. Satellite is moving around the Earth. So what will be the angular momentum with respect to the center of the Earth? Angular momentum, we know r cross p, angular momentum, L vector, angular momentum L. So now see here, Please give the heading, students. Angular momentum of satellite. Angular momentum, angular momentum of satellite. Clear? Angular momentum. It is denoted capital L. Angular momentum actual formula L vector R cross P vector. Right now, P means linear momentum. P vector is equal to M into V vector, and magnitude P only, that is linear momentum MB. R cross P means RP into sine theta. Theta means 90 degree. Here see, in this orbit, satellite is moving in this direction with angular velocity omega. In previous topic, I have told you. Right now, satellite is moving around the earth like this. Am I clear? So here, this is the direction of the velocity. So in this direction, the direction of the momentum like this, along the direction of the velocity V, and R with respect to the center of the earth, direction of the R like this, direction of the R like this. So what is this angle between this? 90 degree. We are taking the angular momentum about O, means this is the direction of earth and this is the direction of MB. Angle between MB and R direction 90 degree. That's why we can write here RP instead of theta, right here 90 degree. Then it will be RP sine 91. Right now, RP into 1, then we will get R into P. And R, P means MB. Here, that is MBR. V means what? The orbital speed of the satellite. Orbital of the speed of the satellite, what was? M, root of R of GM by small r means R plus H. Into R means R plus H. Here right now. Then it will go up power 1. And if it goes in upward direction here, root of R of GM into R plus H power minus half into R plus H. So calculate here M into root of R of GM, it will be R plus H 1 power half, means it will be root. M into root of R of GM into R plus H. Right now, this is the angular momentum of the satellite here with respect to O point, with respect to the center of the earth. I am writing here. We have, all of you write with me, we have got the angular momentum about the center of earth, about the center of the earth. We have got this one. Right now, this is the formula. R plus H you can take is small r, total distance is small r. Also from this relation, you can write here M root of R of GM into R. R means here total distance R plus H. Many times I have written R is equal to R plus H. Am I clear, students? Any dikkat? But what will be the direction of the angular momentum? R cross P. Now see, the satellite is revolving around this direction, R cross P. This is direction of R. This is the direction of R, and P, MB vector like this. P direction in this direction. R cross P as a. Just drive the fingers of the right hand, R to P vector, R P vector, R P vector, R to P vector, R to P vector. Thumb is going outward. Thumb is R to P vector cross, R to P vector cross. Thumb is going outward direction. That is the direction of the angular momentum. Perpendicular. Like this. This is the direction of the angular momentum. So direction of the angular momentum, I am writing here. Also you can write here the direction of angular momentum. Direction of angular momentum outward. Outward direction. Right now I have shown you the right hand outward direction. Clear? L vector, angular momentum outward direction. I have shown you the fingers here. Am I clear? So some topics are left to say of the satellite, the energy of the satellite. Now I will discuss here, students, energy of the satellite. Okay? Have you copied it, students? Any problem? Okay, students, please copy. I am going to the next page. Okay, copied now. I am going to the next page here. All of you give the heading here, energy of the satellite. Energy of satellite. Energy of satellite. Energy of satellite. Now see here, students. Energy of satellite. Again, I am drawing the Earth. This is Earth. Again, draw the circular orbit, in which orbit the satellite is revolving. Right? Satellite is revolving. This is the circular orbit. Center of the Earth, one satellite having mass small m. Direction of the velocity of the satellite v in this direction. This is r. Center of Earth O. Radius capital R of Earth, and height of satellite is small h. That is, r is equal to r plus h. Right now? Now see here. So, satellite is revolving in the circular orbit, in the stationary orbit. Right now? In the stationary orbit. So, here there are two types of energies. For the movement, kinetic energy of the satellite, another energy, potential energy. Potential energy between mass of Earth m and mass of satellite. This is Earth. Right now? This is Earth. M means mass of Earth. M means mass of Earth. Right now? For the movement of the satellite, kinetic energy is available. For the movement of the satellite, kinetic energy is available. Right now, students? So now write kinetic energy of the satellite. First, though, orbital speed we had got v root over of gm by small r, or instead of small r, root over of gm divided by r plus h. Clear? So for the movement of the satellite, kinetic energy of the satellite, k dot e, kinetic energy of satellite, kinetic energy of satellite is equal to half of mv square, orbital speed, mass of the satellite m, by orbital speed of the satellite. Am I clear? Any problem to understand? So now see here, then we can write here half of mv square. V means this one, root out due to the square, then it will be g into m by small r. Then we can write here g into m divided by 2r, or another expression in terms of height, instead of r, then it will be 2 into r plus h. Kinetic energy, now see, positive. Kinetic energy never be negative. Kinetic energy of the satellite, any kinetic energy, any object, never be negative, always positive kinetic energy. And the potential energy between the two mass system, suppose I have told in previous classes. Now see here, one object having mass m1, another object having mass m2, and distance between the center of the two masses is r. So gravitational potential energy U formula you have seen, minus g into m1 into m2, distance between them. Distance should be taken center to center. This is the gravitational potential energy. Gravitational potential energy U is G dot P dot E. G dot P dot E means gravitational potential energy. Okay, I am writing also. Gravitational potential energy. Gravitational potential energy, GPE. Okay, GP, gravitational potential energy. So for the two mass system, gravitational potential energy, mass of the satellite and mass of Earth. This is satellite, right? No, this is satellite. Now here see, potential energy between satellite and Earth Okay, what will be this potential energy, or U, apply the formula minus G capital M into small m, which distance, center to center I have told, small r, or then we can write here minus G into M into r plus h. Potential energy, gravitational potential energy, negative here. This is the potential energy, satellite Earth system. This is the kinetic energy of the satellite. There are two types of energies. In previous time I have told you. So what will be the total energy of the satellite? Kinetic energy plus potential energy, that is the total energy. Am I clear? So now see here students, I am writing here in this position, please copy this. Students, are you copying? No? Okay. Now write with me. Total energy of the satellite here, total energy of satellite, total energy of satellite is E is equal to kinetic energy plus potential energy. Am I clear? Kinetic energy, what is the value? Tell me. G mm by 2r or 2 into r plus h. G mm divided by 2r plus potential energy minus G into m divided by r. Now calculation here, after the calculation it will come minus Gmm divided by 2r, or instead of r we can write here minus G into m divided by 2 into r plus small h. Now see, this is the total energy. E means total energy. Now see here students, total energy minus Gmm by divided by minus Gmm to r, it is the total energy. But one question may come in the competitive or 11 class, board class, why the total energy is negative? What is the significance of the negative sign of the total energy? Actually, for the total energy of the satellite, negative sign is coming. It is the significance that satellite is bound to revolve. Satellite is bound to revolve around the Earth. It is the main significance of the negative sign of the total energy. That sentence I am writing here. Okay, students, please copy with me. Okay, I am here writing. Now see here students, write with me here. The negative sign indicates the negative sign of total energy. The negative sign of total energy indicates or signifies, you can write anyone, indicates that the satellite is bound to revolve around the earth's surface is bound, right? No, it is the main question. It is very very important question. It is very very important questions, very very important, very very BVI for competitive, for NEET and board, right now, for the short question, for the MCQ. Very very important question. What is the significance of negative sign of the total energy? Okay, now see here, please copy this. I am going to the next page. Okay students, देखो, now see here, please copy this. I am going to the next page here. We have got this here. We have got this. Total energy, kinetic energy. Again, I am writing the formula here. G into M divided by 2R. Potential energy we can write here minus G into M divided by R. Total energy E is equal to minus G into M divided by 2R. It is the total energy. And R means radius of earth plus height from the surface of the earth up to the satellite. Okay. But now see here. One orbit I am writing here. Just I am telling. I am drawing. Now see here. Assume this is the orbit. This is orbit, assume. This is orbit, circular orbit. And assume this is the earth. Radius of the earth is capital R. It is earth. Take no? Mass of M. It is earth. Surface. Clear? And from the earth's surface to orbit, this distance height is h. From the surface of the earth to satellite. Here satellite is revolving with speed v. Right now? So small r is equal to r plus h. Clear? So one orbit like this. If first orbit, assume karo, this is the first orbit R1. Another orbit from the center of the earth like this. Another orbit like this. Like this. Having the radius from the center of the earth is, assume R2. Just I have drawn like this. I will tell the significance. Right now? So now see here, R distance from the center of the earth to the satellite, R. R distance, earth to sat means satellite. Suppose R tends to infinity or R is equal to infinity. What is the meaning? Now assume the satellite has gone leaving this orbit. Assume the satellite already left the circular orbit and has gone up to infinite distance. Leaving the circular orbit, the satellite has gone up to infinite distance. At infinite distance, what will be the total energy? For this condition, E is equal to minus G into M, or instead of R, write here infinity, something into infinity, that is infinity. G into divided by infinity. Something by infinity, what? 0. So at infinite orbit, at infinity distance, at infinite orbit, at infinity distance, at infinite distance, the energy of the satellite, total energy of the satellite is 0. Kinetic energy also 0. Kinetic energy formula G into divided by 2R. R to infinity. Here now see G into divided by 2 into infinity, something by infinity, kinetic energy also be 0. Potential energy is equal to minus G into mm divided by r infinity. G into mm divided by infinity, potential energy is 0. At infinite distance, every energy is 0. Total energy 0 means every energy is 0. At infinite distance. At infinite distance, total energy 0 of the satellite. Am I clear? But now see here. Initial energy of the satellite was potential energy. Initial energy what? Of the satellite. Total energy what? For r orbit, for radius r. Take no? Acha. Now see here. The distance r was initially radius of this orbit, in which orbit the satellite is revolving. R is equal to r plus h. Initial total energy EI is equal to what? Bolo. Now say minus G into m divided by 2r. Initial energy means the satellite was revolving in the first orbit, not at infinity. And assume I am writing also, assume the satellite left the orbit and went to the infinite distance, The final energy total at infinity distance, what? 0 at infinite distance, right? No, at infinity distance total energy 0, final energy is 0. EI, this one, total energy infinity is 0. So what is the energy difference? Which is greater? Now see here, students, you have to say, it is the question of the little boy, it is the question of the child. Now see here, minus Gmm by 2r. Now see here, students, now see, minus Gmm by 2r and 0, which energy is greater? 0 is greater or minus this is greater? Obviously 0 is greater, no? Negative, as compared to the negative number, 0 is always greater. So at infinite distance, energy is more. So energy difference del E, energy difference right here, energy difference diff, final energy minus initial energy, whose? Satellite, 0 minus of minus G into m divided by 2r. After calculation we will get G into mm divided by 2r. This is the energy difference. This energy difference, there is name, that is called the binding energy. Whose binding energy? Binding energy of the satellite. Whose binding energy? Binding energy positive is coming. Binding energy of satellite. This is called, now see here, B dot E means binding energy of satellite. Binding energy of satellite. Binding energy of the satellite, right? No. Binding energy of the satellite, if I ask you what is the binding energy of the satellite? Positive. Gmm divided by 2r, smaller. Smaller means r plus h, right? No. So this is the energy of the satellite. On the energy topic of the satellite, one graph is important for us for the competitive as well as different kinds of exams. Now see here, please copy, students. Have you copied? No? Have you copied? Am I go to the next page? Now see here. Now see graph. Graph see here. Now see, students. Now see graph C. Please draw This is the graph. This is y-axis, assume, and this is x-axis, right here. Okay. So y-axis represents energy here. Y-axis represents energy. Y-axis represents energy. X-axis represents distance. Okay. X-axis represents distance. It is energy. It is origin. So kinetic energy always positive. So this is the kinetic energy graph. Why rectangular hyperbola? Now kinetic energy formula, now see this one. It was positive G into M divided by R. Kinetic energy inversely proportional to the distance. That's why the rectangular hyperbola. This is the graph of kinetic energy. Now, total energy graph like this and potential energy like this. It is total energy E, and this is the graph of potential energy. Potential energy. It is the total energy T dot E. It is the kinetic energy graph. Have you understood? Energy distance assume R and energy E. Right now, this graph is important for us. Clear, no? This is the graph. Am I clear, students? Any question regarding this? Am I clear, students? Please see here. Tell me. Am I clear? This is the satellite. Right now? So in brief, I have discussed the satellite, but yet I have not discussed any completive problem. In next class, I will solve the different kinds of numericals. Those numericals have come or may come in NEET and IIT-JEE. Okay, students, all the best. Today up to this. Bye bye, students.